to Sovit Khadka from the New Jersey Institute of Technology with
Hello,
neutral
good
winds.
afternoon.
I'm sorry. Hi.
Hello, good afternoon.
Good afternoon as well. With neutral winds in the Equatorial Thermosphere as measured with the SOFDI instrument. And that is this video.
Hello, I am Sovit Khadka from New Jersey Institute of Technology. This e-poster is about the direct observation of thermospheric neutral wind made with SOFDI instrument, which is currently deployed and operating near geomagnetic equatorial latitude in Huancayo, Peru. The term SOFDI stands for Second Generation Optimized Fabry-Perot Doppler Imager. Most of the direct measurement of the neutral winds are limited to night time only, but SOFDI is designed to measure both day and night time thermospheric neutral winds from 630 nanometer emission of atomic oxygen. In general, the winds are driven by pressure gradient resulting from temperature changes due to solar and auroral heating, and also with forcing by tidal energy from below. Winds play a vital role in the distribution and dynamics of plasma in the ionosphere. So studies of neutral winds are very important for understanding ionospheric behavior and factor controlling the general circulation of the thermosphere, and also to validate and improve existing wind models. Here we present comparison of measured and model thermospheric neutral wind climatology. The figure 1 shows the early SOFDI observation made in August 4 to 11 of 2011. The upper panel of figure 1 shows the geomagnetic condition of experiment day, showing DST and KP index, and the middle and lower panel represents the comparison of wind from SOFDI, CNOF SWM instrument, and SWM 93 model for quiet and strong activity days for meridional and zonal wind respectively. While studying asymmetric structure of EIA, that is equatorial ionization anomaly, as shown in figure 2, by comparing measured GPS TEC and line model, that is low latitude ionospheric sector model TEC, neutral winds are derived and compared with SOFDI wind in lower panel of figure 2. The lines model meridional neutral winds shows reasonably good agreement with measurement by SOFDI instrument that strengthen the confidence of our result. Similarly, in figure 3a, that is left 3 subplots for June 2015, and 3b, that is right 3 subplots for August 2014, SOFDI winds are compared with the SWM14 model wind respectively. The left top panel is for zonal and bottom panel is for meridional wind. The black curve with vertical red bars on it represents the monthly mean of SOFDI wind with measurement uncertainties, which is compared with 100 to 400 kilometer altitudinal profiles of 14 model represented by color curves. Looking at comparison in both June 2015 and August 2014 cases, it is seen that SOFDI and SWM14 winds match climatology in the case of meridional wind. Zonal winds are also likewise consistent except for daytime portion. This deviation might be due to upward moving atmospheric wave or change in emission layer heights. Likewise, in the left two panels of figure 4 showing the evidences of increase in variability of wind as day progresses and becomes maximum in the sunset. Such variability plays a key role in the pre-reversal enhancement and equatorial spread formation in the low latitude. Also, figure 5 is taken from Emirate et al. 2002 paper to see the patterns of summer wind derived from windy measurement. With all these evidences, it is concluded that SOFDI wind matches well to wind obtained from Lyon's model, SWM14 models, and windy measurement except for the daytime zonal wind. Thank you everyone.
Thank you. I'm happy to assist some, answer some question if you have any.
This is N0AX. Are these winds associated with the creation of the ionized layers in the E layer? Do they contribute to the wind shear that creates the reflecting layers in the E layer that HAMS referred to as sporadic E propagation?
Yes, mainly the layer height is we expect around 250 kilometers. So that is the region where like ESF occurs. So it is also one of the source to create, and that this may give some idea to forecast that type of variability.
Okay. There was a good article in QST, I think it was December of 2018, about the relationship between upper level lows in the North Atlantic to observe sporadic E propagation between northeastern North America and Europe on 50 megahertz. And maybe there is some connection there between the upper level lows and what you're studying. I don't know. I'm just thinking out loud here.
So this is this SOFDI is the special property of this SOFDI is that it can measure 24-hour wind continuously. The people are using the February period interferometer that can able to measure only nighttime, but this is especially designed to measure a whole 24-hour day and night time. But our result matches with current models, existing models in meridional wind case. But in the zonal wind sector, like in the daytime section, our result is somehow opposite. Like a positive value is seen in the daytime sector. So we are looking for any other to validate this type of result. We are looking for any other source, like any other type of measurement from in situ, like satellite or any other devices, or from ground if there are any other methods. So from this community also, in HamSCI community, we also propose this type of study that is differently totally different from current model and current measurement people are taking. So our aim is to address the daytime section of zonal wind, which our observation reveals. So we are still working on this day side. If we address, like if there is some engineering problem in the instrument, or the real case of wind is positive, is our instrument reveal in the day side. So we are still on the research about that.
Hi, Sovit.
Yep.
Question. Can you explain, so in the bottom left-hand corner of your poster, you talk about the EIA asymmetry. So EIA is the Equatorial Ionospheric Anomaly. Can you explain to the group what the Equatorial Ionospheric Anomaly is?
So actually, due to like northern and southern hemispheric dynamo that is created by thermospheric wind, that creates one type of intense electric field along geomagnetic equatorial region, mainly points eastward in the daytime. But in the low latitude region, like in magnetic low latitude, I mean equatorial region, the geomagnetic field is almost horizontal to the ground, and the electric field and magnetic field are perpendicular to each other in the geomagnetic equator region. So due to that E cross B drift, upward drift, uplift the plasma, and after a certain height it dumps down along around 15 to 20 degree either side of geomagnetic equator. So this phenomena is called Equatorial Fountain, and due to this Equatorial Fountain, high density electric field, high density electron, the plasma density can be seen around 17 to 20 degree either side of geomagnetic equator. That is called EIA, Equatorial
So
Ionization Anomaly.
like this, right? So
Yes.
yeah. So just for people who may not be quite as familiar, you would think that, just naively, you would think that you would have, if the ionosphere is caused by ultraviolet energy from the sun hitting the neutral atmosphere, you would think that the highest densities in the ionosphere would be right toward the equator.
Yes, but due to special geometry of geomagnetic field and electric field in the equatorial region, the high density occurs around 17 to 20 degree either side of the geomagnetic equator. That
So
is
here and here. So that's called the Equatorial Ionospheric Anomaly, or the EIA.
Equatorial ionization anomaly, and the density in these two anomaly will be altered by thermospheric neutral wind. So in the figure 2, this is already published material. If you want to know details about it, it is a published material in 2018. I am the first author in radio science. It is published in radio science, and we compare with Lyons model. Actually, the Lyons model gives TEC value, but I use like inverse modeling technique and compared with direct measurement of TEC obtained from LISTEN network, that is low latitude ionospheric sensor network. There are around 50 GPS in South America, and compare with Lyons TEC, and I generated thermospheric neutral wind value, meridional wind value, and that is almost comparable with the direct measured wind from SOFDI. So this is published material. Figure 2 is published material.
It's
so
about 1 minute.
Asymmetry structure of for the asymmetry structure of wind, also the EIA also, that wind play important role.
That sounds good. Let's
So, but I just had a quick question. Normally I'd walk down the hall and ask you this, but the governor just said we have to all stay home now, so that's not going to happen. Is this instrument SOFDI still operational now?
Yes, it is still operating in South America, Huancayo, Peru, mainly June, July, August, 3 months of every year.
Okay, is there any way to operate it like 24? Is that?
Yes, June, July, August, 3 months of every year. From
Okay.
2011 to 2019, it is still operating.
So is it operational? So we're waiting until summer to turn it on again?
I think there are people, and they are operating this like for 3 months. So
okay, thank you.
All right, thank you so much, Sovit.